Everybody, welcome back to another fun and exciting Algebra 2 class. Today we are going to be in chapter number 10, lesson 2. Lesson 2 talks about what's called series. And this is not like series, like multiple Siri, the person on the iPhone. That's not the same person here, okay? This is series. It's spelled different. This is like the World Series, okay? What is the World Series? Well, it's a group of games that all count toward making somebody the champion. Well, this is exactly what's going on here. It's a series is a sum. If you look down here at the screen, it says it's the sum of the terms in a sequence. So if you add the sequence up, it becomes a series. And that is, I guess, the mathematical definition. We are on page number, if you're wondering what page we're on page 456. 456. You like that? I do. So, you think they did it on purpose? You think they put series on 456? You see how it adds up? You see how it counts? Maybe. I don't know. That would have been cool if they did. But anyways, let's go through this. So you guys are going to feel lost, I promise you, because all of these words are like brand new to you. You've never heard them before. But stay with me, hang in there, and then we're going to bring it all back together near the end of the lesson. Hopefully, it will all start to click. Okay? A series is the sum of the terms in a sequence. The Greek letter sigma, that's that like sideways looking M thing, is used to represent a series. It is referred to as sigma notation. So here is a little bit of sigma notation for you. This is kind of what it looks like right here. Sigma notation is it equals this. Basically, that is, you don't have to worry about this right now. I don't even know why I wrote it, to be honest. It's in your book if you want to see it. But that is just like what later on in the chapter we're going to be doing that. But for right now, you don't need to know it. All right. So this right here is what's called the argument, this a to the I. And a to the I can look different. It can be different. That a can look a little different. The I can look a little different. But that piece right here, this piece that's right next to the sigma, is called the argument. It's kind of like the argument when we did the logarithms and things like that. It's a little bit different though. Some students get confused right here and they think that this I right here stands for imaginary. It does not. It stands for index of summation. So the I is called the index. I guess the best way to say that is the index is like where you find it, like where you would look it up, where you would start looking. Like if you go into the library and you go to the index, or into the book and you look in the front of the book, you're looking at the index. You're looking where to find something, okay? And so this index is kind of like where to find it, where to start looking at it. And again, like I said, you're going to be lost. You're going to be like, what is this guy even talking about right now? Don't worry. I'm going to try to bring it all back around. So by the end of the lesson, you're kind of like, oh, okay, I get it. The M is the lower bound. All right, the lower bound. The lower boundary. In other words, that's where you start counting. The M is where you begin your counting of the sequence, okay? Because that's what a series is. It's the sum, it's the adding together of a sequence. The N is the upper bound, and the N goes up here, okay? So the N is the upper bound, the M is the lower bound. That makes sense, right? Because the M is on the lower part of the sigma, the N is on the upper part of the sigma. That should make sense to you, okay? So those are the pieces of the sigma notation. And again, if you don't understand any of that, if it sounds like a foreign language to you, it's okay for right now. All right, let's look at example 10.2a. It is on page 456. If we're going to evaluate this series, what are we going to do? Well, the series is, look what it says, and this is interesting. I want you to understand this. When it says 1 over I, remember how I said that this argument can look different sometimes? Well, here's the very first example, and it looks different. It's 1 over I. Well, what does that mean? Well, what is I? It says right there that I is 1. So here's what it is. It's 1 over 1. Okay, and we go until 4. So the upper bound of that I is 4. So if the denominator is 4, we'd say 1 plus 1 over 2, 1 plus 1 over 3, 1 plus 1 over 4. And that's the upper bound right there. Now what we want to do is we want to add it together. So we can't add these together until we make them a common denominator. So 1, 2, 3, and 4, the common denominator of that is 12. So we're going to make all of these common denominator of 12. And we're going to add them all together after we do that. So what does it take to get to 12 here? 1 times what? 1 times 12. So 1 times 12, that's 12 over 12. Here, 2 times 6, 1 times 6 is 6. Here, 3 times 4 is 12, so 1 times 4. Here, 4 times 3 is 12, and 1 times 3. All right, so there we go. Now we just add them together. And so let's see, that's 10, 22, 25. 25 over 12 is our answer. That's it. That's all we do, okay? We just add our things together. That's what this is about. This is a sum. This is a sigma notation, which signifies that we're doing a series. What is a series? It's a sum. It's a sum of what? It's a sum of numbers in a row. Look, these numbers are in a row. 1 over 1, 1 over 2, 1 over 3, 1 over 4. Why did we stop at 1 over 4? Because that's where the upper bound told us to stop. Okay. All right. Let's talk about this next little section here. It is on the next page, 457. 457. Actually, this first one is on 456. Series of a constant. What is the series of a constant? A series of a constant is when the I, remember how I told you the I can look different? When the I is a constant. Okay, what's a constant? When the I is a number, it's just a number. Here's what you do. You just take the C or the constant times the N. The constant times the upper bound. That's all you do. You have it solved. That easy. Next, the series of consecutive integers. I'm sorry, that looks really terrible right there, but it's supposed to say consecutive integers, and it looks bad. My handwriting is bad, so forgive me. All right, so what does this look like? This looks like, this is on page 457. And here's what this looks like. This is a little formula that they give you. So what you do is you take this formula right here and you just plug into it. So when you get this right here, when I is just an I, so here's what that means. I is whatever this equals. I equals 1, so you're going to put a 1 here, okay? There's not a constant there when it has an actual I there. It's telling you to start with the lower bound. So what do? You plug in your N, your upper bound here, you plug in your upper bound here, and you just do the math. That's all you do. You just solve the formula. We're going to do it in a second, but I just want to go over the formula with you first. So there it is. Okay. The next one is a series of consecutive squares. What does that mean? So now you have your I is squared. So when you have this, here's what you're going to do. You're going to use this formula. So you're going to plug into N here, you're going to plug into N here, and you're going to plug into N here, and then you're going to solve your formula. Okay? It's really not that bad. It looks bad. This thing looks like, oh my goodness, what am I going to do? But it's not that bad. All right, let's look at it. Here's one right here. Notice that here I have a what? I have a constant. Okay, so what one am I going to use? I'm going to use the series of a constant, because right there is a constant. What's the formula? This is the easy one. This is just Cn. So we come down here and we're going to say, okay, what's our C? What's our constant? It's 3. What's our N? It's 7. I'm just going to take 3 times 7, and I'm going to come up with 21. Okay, that's it. That's your answer. Yeah, I can't make it any harder. I wish I could. I wish I could make it harder for you, but I can't. And if you're wondering where I am, Sometimes I wonder where I am too, but I am on page 458. Page 458. Okay. All right. The next one is right here. So we have our series, and our upper bound is 8. And look, remember when I told you sometimes it's just an I? All right, so it's just an I there. And so this one is what? This one is the series of consecutive integers when it's just an I right there. So let's go ahead and use that formula. What's the formula? It is n times n plus 1 parentheses over 2. So let's plug into it. 8 times 8 plus 1 divided by 2. Do inside the parentheses first. So we're going to have 8 times 9 divided by 2. Okay. 8 times 9 is 72 divided by 2. 72 divided by 2 equals 36. So there's your answer, 36. Not bad. Not as bad as you thought it was going to be, is it? I tried to tell you. You don't listen to me. All right. Here we go. Here's one more. All right. This one, notice it has the square. So this one is the consecutive squares right here. This is the little bit bigger formula that we talked about. Okay. So now we just write down our formula again. And so it's n times n plus 1. And that's the same as this one. Okay. That's this one. So now we have to do the squared part of it, and that is 2n plus 1. And you'll see how that kind of squares it in just a second. And that's divided by 6. Okay? Just trust me on the formulas. You just got to plug into them. The only thing you need here really is the upper bound. You're just going to plug the upper bound in those 3 spots, and you're going to get 6 times 6 plus 1 times 2 times 6 plus 1. All right, so 6 times 7 times 12 plus 1, 13 divided by 6. At this point, I'm going to defer to the old calculator, and you probably should too, unless you're just really, really intelligent. So 6 times 7 times 13 equals 546 divided by 6 equals 91. And there's our answer, 91. Okay. So there it is. There is the introduction. I'm just going to do the A part of series, and then I'm going to do a B part. There's just too much to get into one lesson, I think. So I'll be kind to you on this one. Last lesson is a little bit long, so I'll shorten this one up a little bit. Okay? Well, that's all I have for you for this part of the lesson. We'll see you later. Have a good one. Bye-bye.